You are welcome to Chemistry Hangout. First of all, let me salute all chemistry educators around the globe. I love you guys. I understand the pressure that we are in. You know, sometimes if we want the best for our students, we want to do every possible thing, do our own part so that there will not be fault on our part. And that's the reason why we are doing this live video again today. We're going to do a lot of things today. Today, I'm going to be taking us through how to prepare reagent because I've had different title values flying around. But nevertheless, the first thing is let's get the preparation first. Then when we get the preparation first, we can now tell what is the problem if we're not getting the right thing. So today, I'll take us through the preparation. After I've taken us through the preparation, I will titrate it so that we'll see it. I have prepared my own, but I will tell us what to do, how to dissolve. And very important again, I will show us, the chemicals that we have been buying. Some are hydrated anyway because of the pressure, but a lot of us got dehydrated. In fact, I was not able to get the hydros. That's the truth. I was not able to get the hydros, and it's gave me a lot of pressure because I know what WAEC actually gave us is the hydros. So I had to sit down. What can be done? This is chemistry. This is a problem. If there is a problem, there must be a solution. And I tell you, what I used is the hydrated. Yes, and I'll tell you how we are going to convert the hydrated sulfate to the what? To the hydros. So, peradventure, you did not get the hydros maybe because it was not readily available. We are going to show us now how to actually do our calculations to make sure that the hydrated we can still use it, but we just do a mass, we just do a mass calculation. So I'm going to take us through this again, and I'm going to give us instructions. It's my own humble opinion. You can decide to make use of it. You can decide not to make use of it, but we have to do this live to help my co-chemistry educators and students alike. So very quickly, what they gave us in the instruction, let's get what they gave us in the instruction, please. Let's get what they gave us. What did they give us in the instruction? Let's get it first. Let's get that first. So we know, for people probably that might not have seen it, what did they give us in the instruction? Let's say 2024 WAEC Chemistry Preparation. Chemistry Preparation. I want to say this. Some people have called me and they were like, WAEC did not specify if it is hydrated or hydros. But I stand to be corrected, that is not true. What WAEC gave us was this, FeSO4. This is an hydrous salt. If WAEC want us to use the hydrated, they would have specified FeSO4.7H2O. If you remember last year, for my co-educators that were around last year, you see they gave us sodium carbonate decahydrate. That's what they gave us. So, and they know we have hydrous sodium carbonate. So, but they want us to use the decahydrate. They gave us, said Na2CO3.10H2O. Please, one of the ways to solve problem is to first obey instructions. Very important. We obey the instructions. So what WAEC gave us is this, not this. And what is the mass of this? They asked us to measure. They said 5.5 gram of this in 1 dm cube of solution. That's what they gave us. Just pay attention, guys. So why they now give us 1.58 gram of KMNO4 in 1 dm cube or per dm cube of solution. Anyone is correct. How do I prepare this first? Let's get the preparation first. How do I prepare this? Let's start with our KMNO4. How do I prepare my KMNO4? I will accurately weigh 1.5 gram of KMNO4. When I say accurately, most importantly, if you want to get this accurate measurement, please use an electronic balance. For me, I can use my triple beam balance, I can use my electronic balance. I'm vast using the triple beam balance. Some of the chemistry teachers that have bought some of our courses where I used the triple beam balance to get same readings with an electronic balance. So even these ones that I prepared, I actually used my triple beam balance. The KMNO4 I prepared, I used my triple beam balance. I think I used the electronic for the FeSO4, but I used the triple beam balance for it. So accurately weigh 1.5 gram of KMnO4 in, let's say, 250 centimeter cube of a beaker, of 250 centimeter cube of a beaker containing small amount of water. I will explain this. So what I'm trying to say is that before you prepare this, take a 250 centimeter cube of beaker or 500, 250 or 500, anyone you are having, put little water inside. Then after you have accurately weighed 1.5 gram, 1.58 gram of KMnO4. Do you get that now? You are now going to add 1.5 gram of KMnO4 into the 250 centimeter cube of beaker. Either 100 ml of water is there, any of the water that is there. So measure this 1.58 gram accurately, then dissolve it in a beaker, 250 centimeter cube of beaker or 500 that has small amount of water. Then you now look for this. You know, this is a 1 dm cube volumetric flask. This is a 1 dm cube, 1000 centimeter cube is equal to 1 dm cube. So what will I do? I will now transfer the little water that I have. You know, I have dissolved this 1.58 in beaker now. I will now transfer it into this place. So when I transfer it into this place, you will still be seeing some remnant of KMnO4 because everything will not dissolve instantly. So you are still going to pour small amount of water in that very particular beaker again, pour everything inside until all the KMnO4 in the beaker is transferred into this place. I want to believe this is clear. When you now transfer it into the 1 dm cube beaker, you now fill it up to this mark. There is a 1 dm cube mark here. You fill it up to this mark. Then if you fill it up to this mark, cork it and let it stand for hours. The reason why I said let it stand for hours is because I have prepared this thing before. And because of the nature of KMnO4, it might not dissolve instantly. So I have to leave it for hours to equilibrate. Okay, sorry, I'm using the chemistry to dissolve well. Okay, so I have to leave it here to dissolve well. So which means my KMnO4 is what? Is settled already. If I do this, it's settled. You can ask your question. You can ask your questions, you can type your questions, ask your questions so that I can answer some of them. If not, if I can answer. So which means this is settled already. I don't know if this is clear. This is settled already. Okay, so KMnO4 settled. Now let's go to this. Please pay attention to this now. Pay attention to this. For 5.5 gram of FeSO4, they didn't tell us this, but I'm going to show you something that I got, and I think it will be good I share it with my co-educators. I will tell you how to use this. This is the one they asked us to get, the iodous iron sulfate, according to the instruction in the question. This and this are not the same because the molar mass are not the same. I want to believe this. This is what they asked us to do, but I will show you how to use this before the end of this video. So which means for the second one now, what do I do? You know, 5.5 gram, same thing. Take another beaker. You get that? Put small amount of water in the beaker, either 250 centimeter cube beaker or 500, anyone you have. Accurately weigh 5.5 gram of FeSO4. I want to believe this is clear. Accurately weigh 5.5 gram of FeSO4 in 250 centimeter cube beaker containing, you know, you would have just put small volume of water there, amount of water or volume of water. Let me use the word volume. Small volume. Let me use the word volume. That's scientific. Use the word small volume. Okay? So which means take another beaker, either 250 or 500. Can you see that now? Don't forget we are done with this. Take another beaker, either 250 or what? Or 500. Put small volume of water there. Weigh accurately 5.5 gram of FeSO4, not FeSO4.782. FeSO4. Just calm down. I'm still coming back to this. So weigh this and what? Put it in that beaker. That beaker you actually put small amount volume of water there. You now transfer this 5.5 gram of FeSO4 inside. Now look for another 1 dm cube again. 1 dm cube volumetric flask. Okay, transfer everything in the beaker. The FeSO4 you have measured and the water, transfer it into the 1 dm cube. Okay, there will still be little FeSO4. in the beaker that you use. Put water again, make sure everything is transferred to the 1 dm cube and make it up to the same mark, 1 dm cube. But very, very important, please, you have to cork it. Look for this, not 1000, this is 250. So you have to cork it because your FeSO4 can oxidize. Do you see that? If you leave it open, it will oxidize. So you have to cork this thing. Make sure it is airtight, okay? It is airtight so that it will not oxidize. Then which means you have done this, you have done this. I want to believe this is clear. So you have done this, you have done this, that is settled. I want to believe somebody is still on this video. Settled, the 2 now is settled. So this, I'm still coming back to this before the end of the video. This is settled, this is settled. Now, for our 2 molar H2SO4, don't forget, I said we'll be using 2 molar H2SO4. How do we prepare that? Measure 111 centimeter cube of conc H2SO4. Okay, dissolve in about 200 centimeter cube of water and make it up to 1 dm cube. So if you have done this, it means you have prepared 2 molar H2SO4. How do we do this? Take your conc H2SO4. It's always in this bottle. This is our stock bottle now. Our stock bottle. Measure 111 of it. Look for probably a beaker. Look for a beaker because the mouth of this is not that wide. So look for a beaker. Pour small amount of water in that beaker. Do you get that now? After you have put small amount of water in that beaker, then measure this 111 centimeter cube of H2SO4 and pour everything inside. I want to believe that is clear. After you have poured it inside, look for 1 dm cube of volumetric flask again. Look for 1 dm cube. Then transfer everything into the 1 dm cube. Okay? Pour water in that beaker again, transfer it into the 1 dm cube and make it up to the mark of the 1 dm cube. Meaning you have prepared 2 molar H2SO4. So what we needed to get our titration done is 5.5 grams of this. I've explained how to do that. Our K-menu for 1.58, I've explained how to do that. And for people that have been calling me about the 2 molar H2SO4, this is the way you prepare it. I think that is set. And that is what I have done here. Very important. Now, after we have done that now, we have accurately prepared that. That's the first stage. We accurately prepare because that can determine how much it will affect our titrations. Yes. So after we have accurately prepared this now, we now want to titrate. Then after the titration, I will now show you something I know. I was just worried because a lot of places, very few people got the hydros. Even me did not get the hydros. What they supplied me is this. So I was like, is there no way we could do something? Because this is a problem already. And time is not on our side. The exam is fast approaching. So I have to do something which I will show you. So even me, I did not titrate with the hydros. I titrated with the hydrated, but I did something which I will show us before the end of the video. So let's titrate now. Very important. Let's just see what our value. So the K-menu file prepared is here. And people that have been calling me that which one will you acidify? Please, we are not acidifying the K-menu file. We are acidifying the iron 2 sulfate. And that's why I'm doing this live class to clarify this once and for all again, please. So this is it. Let me fill it up to my 0 mark. Let me fill it up. Let me fill it up. I think it's more than the mark. 9 to 0. Okay, now please let the camera come closer so that we see it. You know, I talked about taking the upper meniscus, if you remember, because this solution is colored now. I cannot see the lower meniscus. I can only see this colored one here. You can see that's I'm taking the up one, which is 0 here now. So which means my initial readings is actually 0. I'm taking the up one because I can't see all these bullets now, except this K-menu for begin to get used, and I'll be seeing those readings. I don't know if you are getting that. So this one is 0. Clear? That's K-menu 4 in the burette. I hope you are still following me. K-menu 4 in the burette. This is my iron 2 sulfate that I prepared. Okay, so let me pipette this. 25, I'm using 25. Okay, 25 now. You need 25. Okay. I hope I'm still following the live class. So this 25 centimeter cube of my iron 2 sulfate. Okay. Then I will acidify it with my, let me wash this with water. Let me wash this because I used it for the Okay, so I'm measuring 10 centimeter cube. Now I'm using 10. I'm using 10. Now, you know, I talked about 5. We can use, you know, this is the exam, can be 5, can be 10, but I'm using 10 now. I'm using 10 mil of this. So let me measure this. This is my H2SO for 2 molar that I prepared. So let me measure 10 centimeter cube. Maybe I will use 5 too and see what it will give us. But I think I used 10 when I did it. So let me first of all use 10 to confirm. Okay, it's very little. It's more than I'm using 10. So let me run off. Okay, so come and see that now. This is 10 now, you can see. This is 10 now. So into my iron sulfate, you can see I'm using 10. This is my measuring cylinder. You can see it now. So I'm now putting it in my iron 2 sulfate. You see that now? I'm putting it in my iron 2 sulfate. That's why I'm taking us through this process. I know a lot of chemistry teachers have been stressed, but you know, it happens like that from experience. It happens. So let's start our titration now. Let's go. Sorry, let me. Okay. Let's still continue. Can you see that now? You are still on. Let me slant in my red, very important. Okay. Let's go. Okay. So you have to be very careful here so that you don't overrun the FES so far. I'm still on. Gently, please, so that we don't overrun. Let's go gently now. Let's go gently. You have to be very careful. Did you see it? I want to believe you are seeing this. Did you see the color? Now let's check. This is 17. You can see. This is around 17.90 because not. I'm seeing it. You can see this is 18 now, but I'm seeing around 17.90. It's not up to 18. I'm seeing around 17.90 for my. You can see this is 18 here. That's why I'm zooming the camera so that you see. This is around 18. So that's 17.90, around 17.90, 18.00. That's what I'm getting. So one thing about science is this: theory doesn't lie. I tell you, doesn't lie. Which means some people have been calling me that, sir, the theoretical value is around 18. Of course, the theoretical value is 18, but did you get 18 when you did it? No, I'm still coming back to that. But if you are accurately prepared, you can see there is no any. That's why we say it is a pale pink. Do you see that now? So everything set 18. is gotten, right? So which means that we have accurately prepared this, because the theoretical value is around 18.10, the theoretical value. But it's not a matter of using the theoretical value. I was speaking to a friend and I said, imagine you did this titration, you got 11, and you're not telling students to use 18. It doesn't look professional. I don't know, it doesn't look professional. I don't know how you guys see it, but it doesn't look professional, because the students will be, why is it that we got 11 and you are telling us to use 18? That will be the question they will be asking you. Okay, we are still coming back to that. So for my own, I got it at 17.90, 18.00. That's the title, the average title I'm getting. However, now let's come back to this. And that's what I said I want to show you guys. Let's come back to this. I'm still going to answer questions. Let's come back to this. For people that want to use this, you can still use it, which is what I used. I didn't get their hydros because it was scarce. In fact, some people were bringing adulterated chemicals that are fake, because they know the pressure on us and we need to prepare students. So how do we do it? This is the one that is available, but according to instruction, this is the one WAEC asks us to use. Let's do something here. Let's calculate the molar mass of these two. For iron, we are going to have 56 plus 32 plus 16 times 4. That's for this one. So this will be, which is what I actually came up with. So, which will be 56 plus 32 plus 64. I'm showing you what to do. If you have this, you can still use it. Don't return it. You can still use it. So let's have my calculator. 56 plus 32 plus 64. So this is 152 grams. I want to believe we are clear. Let's calculate for this. FeSO4.7H2O. I don't need to waste my time. This is already 152. So this will be 152 plus, then we have 7 into 1 times 2 hydrogen. That will be 2 plus 16. Then it will be 152 plus 7 into 18. Then we have 18 times 7. That's 126 plus 152. That's 278 grams. I want to believe this is clear. So 1 mole of FeSO4 is 152 grams. 1 mole of FeSO4.7H2O is 278. Now look at what I got. And in fact, when I got it, I was like, I need to get, because if you remember, in the first video I did, I said in the vertical that you should not use this. The reason why I said you should not use this is because the only way I know that you can convert this is stressful. Of course, this can be converted. How? You can just eat this, and because it's water of crystallization. So when you eat the salt, what happens? All the water will be given up, but you have to be weighing intermittently. So it's stressful. Even me will not want to pass through that stress. That was why I was saying you should not use this. But I now discovered a lot of people were calling me that this was what was available. Even here at my place, this one was not available. I've called a lot of chemical stores. They could not supply it. They said this is the one they have. So and I think that is a problem. Then we can look for solution. That was why I came up with this. So look at this. Look at this now. So which means 1 mole of this of FeSO4 is 152 grams, while 1 mole of FeSO4.7H2O is 278 grams. I want to believe, let me change my marker. I want to believe we are still together here. Now, what will happen? Now look at this. If 152 grams of FeSO4 is 278 grams of FeSO4.7H2O. Look at what I did. 152 grams of this is equal to 278. Which means they now ask me to prepare what? 5.5 grams, and I don't have it. So which means if 152 grams of this gives 278 of this, and I want to use 5.5 grams of this one. Do you see that now? So what is 152 of this will give this 5.5 grams, which they asked me to measure. You know, WAEC asks us to measure this 5.5 grams. I don't have it. I want to use this. So if 152 grams is 278, 5.5 grams of this will now be what of this if I want to use this. I don't know if you are getting it. So which is will now be x. So I now have x is 152. Sorry, x will be 5.5 times 278 over 152. So S will be what? Let's check. Times 5.5 divide 152. And that's giving me 10.06 approximately. 10.06. Guys, I want to believe this is clear. So, which means if I did not add this, I can use this. But the only thing is that instead of me to measure 5.5 gram, I will measure 10.06 gram. So that is what I did. I want to believe we are getting something. That's what I did. So since I did not have this, so instead of me to use the 5.5 gram of this, because this is what we are meant to use. I don't know if I'm explaining something here. This, we are supposed to use 5.5 gram of this, but it's not available. This is what is available. So which means 10.06 gram of this is equivalent to 5.5 gram of this. So 10.06 gram of the hydrated is equal to 5.5 gram of the anhydrous. And that is what I used. So instead of me to measure 5.5 here, since I am using this salt, I now measure 10.06. So I measure 10.06 of this, and I use for my temperature. And that's why I got this. So if you have your iron 2 sulfate hydrate, you can use it. So that one will not cause a lot of confusion, and it will be as if we are not ready for the exam. So we can use it. So for teachers that are watching me, please, you can try this. I have explained all the process, but don't forget, if you have the anhydrous, do you understand that if you have this, you have to measure 5.5 gram because you have the anhydrous. But if you have the hydrated, if you have this, just measure 10.06 gram of the hydrated. Then use it for the titration and to get your value. Again, please, we cannot get the same value. I think let me talk about that. We cannot get the same value as teachers. But however, your values should not be too wide. I don't know if you are getting that. Since we are saying the titer value is around 8.1 theoretically, and you are now getting 3 centimeter cube. 3 centimeter cube is far from 18. Do you understand that? It is not compulsory everybody. That's the reason why, even if you did not get 18, we are not saying you should get 18 by force. I have spoken to some people, they got 15. I have spoken to some people, they got 16. It's okay. In as much as that is what you are feeling in the report on that day. Titer value should not give us problem. And that's why I spoke about it even before now. Titer value should not give us problem. That is why WAEC gave us a report. And they are using your report to mark that center. So if you say your titer value is 14.60, then that is your titer value. In as much as that is what you have recorded in the report form, that is what they are going to mark that center with. I want to believe that is clear. So don't begin to call somebody and begin to panic. What's the titer value? I'm not getting the same thing. For me, I expect, that is my own opinion, I expect the titer value to be greater than 10 for this titration. The titer value to be greater than 10 or less than 23. Or even less than 22. Let me use that. I don't know if that is clear. So at least if you have a titer value greater than 10 and still less than 22, you can use it. In as much, you can see my statements, in as much as that is what you are recording on the day of the exam in the report form as teacher. That's why WAEC has to provide us with report form, because they know the titer value cannot be generic. They know it cannot be the same. That's why they are giving every center, fill your own, you fill your own, you fill your own. Because one of the things that can make you not get the same titer value, the solution too is important. So understand that the titer value is not generic. We cannot have the same titer values. So please, that's my own humble opinion. I said if you have done it very well, your titer value should be greater than 10, or if it's greater than 10, maybe you get a value above 18, at least it will be less than 22. It will still be balanced. But listen, if you have done all this preparation that I have said, and your titer value is still around 3.5, then the reagent is the issue. If you have accurately measured all this and you have done this, don't forget, if you are using FeSO4, that's your hydrous. If they say it's the hydrous, you are measuring 5.5. But if you are using the hydrated, that's the hydrate, you are using 10.0. If you have done all this and your titer value is still very small, like you are getting 3, like some people have told me you are getting 5, that means the reagent is the problem. Yes, because this is just the steps for preparing the reagent. And I've titrated, you can see, titrated it and you are seeing my value. So if you still get a titer value that is very low, maybe 5, 6, it's still very low to me. It's is a bit low. So that means the reagent is the problem. And for the new chemistry teachers, let me say welcome to the fold. You know, some chemistry teachers joined us when we have this readers. I think by my own research, I have seen readers in 2016, 2018, 2019, 2022, and 2024 now. That's 5 times. I'm still expecting readers next year. Yes, I'm still predicting that they will give us readers next year. So they have been giving out, I think this is about the 5th time. But if you're a new chemistry teacher, welcome to the fold. You know, sometimes it is stressful like this. But these are you know, what actually built us to. These are the tenacity, the confidence, you know, we have to keep going, and with time, you will get accustomed to it. So please, if you are just new to this subject, you are just, you know, you are just leading your student for the first time for WAEC, you know, a lot of expectations are going to be on you, there's going to be a lot of pressure. You need to get out to prepare reagents, not just, I have somebody that called me last year, how would I prepare 1 molar? You are still calling me this year, how would I prepare 2 molar? To me, it's not too fair. We need something that will make us understand this. What if you cannot reach me? What if I'm busy and I'm not able to reply your chat? You know, so like some people have been calling me massively. So how do we prepare this? If you have gotten all these videos, you will not be coming to say, okay, NECO is still coming in a few months' time. We used to be calling me. Let's say, for example, they asked us to prepare 3.5 HNO3, 3.5 molar HNO3. I used to be calling me again for NECO that I should tell you, you know, it doesn't look so well. You know, as a teacher, we are a resource person, and we should try all our possible best to get value so that we can lead these students to success. So I love you guys. This is just the preparation. This is what to expect, the title values, and again. So if you're a chemistry teacher and you are new to the fold, you need to understand all these things. Not just for only this year WAEC. WAEC is continuous. It's every year. It's every year. NECO is every year. So we need to understand the holistic, you know, the holistic picture of how to prepare laboratory reagents. If you find something difficult, how can you troubleshoot where the problem is coming from? So very important. So if you still do all this preparation and the data value is still very low, you're getting 8, you're getting 5, you can probably change the reagent. You can get another reagent, or if you have a friend that lives very close to you, get reagent. But we should not panic. Our report is our power. Anything you feel in the report is what they are actually going to mark the students with. So very, very important. So I will try for predicted question. You can DM me, because predicted question is not in this, so that it will not be too large. This is about the video now should be more than around 25 minutes, so that I don't get us bored. So the predicted question, I'm going to do it in another video, so you can private chat me for the predicted question for this year titration. I love you guys. For chemistry teachers, you know, thanks for the sacrifice. You know, all we are just doing is to make these students successful, and I hope that all our efforts will not be in vain. So let's just keep doing our best, still giving our best. We know things are not encouraging, probably some schools too are not encouraging, but you know, sometimes it is for our own good first. When we get value, anywhere we are, we can stand and say, no, this is how it is being done. So I salute every co-educators, chemistry teacher, science teacher. I salute us. For people, thank you guys for your massive comments, your words of appreciation. I love you guys. I'm not perfect too. My analysis is my own opinion, okay? So it's my own humble opinion, okay? So some people will come, please, when you are criticizing, try to criticize constructively, okay? We too, we are doing, I have to just sit down to get all these too. There is no textbook that will tell you all these things, you know, but we are just trying to be a better version of ourselves and to serve the populace better. So for people that have reached out to me, the prayers, thank you so much for the airtime, for the data. You guys are wonderful. You guys are amazing. Thank you so much for appreciating our work on this channel. Thanks for the kind words and words of motivation. I love you guys. So you can private chat me, very important, so that I can send you the video. You know, the video for it will not be in this video, it will be in another video. And probably, you know, sometimes appreciation too matters. You know, sometimes we don't appreciate what we are. We don't appreciate ourselves, and it is not that good. So let's learn to appreciate ourselves too. So if you DM me and we are giving you some conditions that, okay, you need to give us a token, it's not bad. This reagent, we have to get it. You have to go extra miles to get a lot of things. Sleepless night just to make this video. Me and my crew now, we are here. It's already dark. We are doing a live video. There must be lighting, there must be everything. You know, sometimes it's actually frustrating, but you know, we just want to do our best. We just want to do our best. So to not be in this video, you can private chat me, then tell you what to do, then probably you get the predicted question for titration and the qualitative analysis. I love you guys. For all 2023 WAEC students, I wish you success. I wish you the best. I wish you success. Thank you so much. You can share this video to your friends, co-educators. You can share it to your co-teachers too, so that at least they will not be running a scatter because I'm giving a time grade. I love you guys. Students, I love you guys. My distinguished educators, I love you guys. This is Chemistry Hangout. If you have not subscribed to this channel, you are missing a lot. Subscribe to this channel and follow us on Facebook. We're on Facebook. You can follow us on TikTok. We are there, Chemistry Hangout, on YouTube, on TikTok, on Facebook. Just follow us so that you don't miss any of our updates. I love you so much. Stay chemically active. Bye bye and thank you. Till we meet again. I love you guys. Thank you.